Hello, good evening everyone. So sorry, in the lecture 8 we had to stop the lecture in between. So this is in the continuation of that itself. Fair. So what I'll say is persons who are new to this lecture only, they are suggested to go through the lecture RL-8 as well. Fair. Because we were doing something, suddenly we stopped just due to my ill health. But now we are continuing from there itself. Fair. So just let me share the link with others so that they can join. Hello, good evening. Good evening everyone. So let's wait for others to join at the class and start them. Good evening. Just 2 minutes, we'll wait for others. I guess I should start, right? So persons will be joining sooner or later. Let me do my work. See, till now we have discussed so till now we have discussed about subsequences, monotone sequences, monotone convergence theorem as well we have discussed in the lecture RL-8. So now we will be continuing from there itself and will try to know how this monotone convergence theorem works, how like maximum PYQs are based on this theorem. As far as real sequences are concerned, my dear fellows, maximum number of questions can be done from the monotone convergence theorem as far as our CSE exam or forest services is concerned. So here we are not going to do the PhD over the things. We are very much confined towards our systematic learning as demand of the exam. So this is the question which we were doing. The sequence ka nth term was given. So this is the first example regarding the monotone convergence theorem. So I would like to take the proper time here to elaborate things well. Yeah. So देखिए whenever you want to check कि some sequence is convergent or not, to check the convergence, what you have to do is, my dear fellows, सबसे पहला काम जो होता है, the very first step is the observation. क्या करना है आपको? Observe the terms. Dear fellows, once you learn this, once you adopt this, you will feel enjoying this topic. Believe me, my dear fellows. ठीक है? So एकदम बच्चा लोग की तरह पहले टर्म्स को ऑब्जर्व कीजिए. Means given sequence is actually what? ध्यान से देखते रहना. That is the first step. So since we have given the sequence का nth term, right? Sn represents the nth term of the sequence. Fair? So Sn is given like this. I am interested what is the sequence now. देखना ध्यान से. Be on the board please everyone. One small request from my side, क्योंकि हेल्थ उतना साथ नहीं दे रहा है करके, तो थोड़ा सा मैं स्लो हो सकता हूँ, तो प्लीज कोऑपरेट, है ना. मतलब मैं मेरी तरफ से बेस्ट ट्राई कर रहा हूँ, क्योंकि सुबह का गिल्ट जो है मेरे को, क्लास बीच में छूटा, वो मतलब बहुत ही गंदा फील हो रहा था. एनीवेज, देखना प्यारे बच्चों, इफ Sn is this, so if you observe my dear fellows, देखना ध्यान से, ऑब्जर्वेशन क्या है, nth term of sequence is sum of n terms. ऐसे ही तो दिया गया ना, देखिए, for all n belongs to natural numbers. अगर मैं for example if I want to write S1 क्या होगा, बोलो. अगर Sn जो है वो n टर्म्स का समेशन है, तो S1 will be sum of one term, S2 must be sum of two terms and so on. इतना लिखना सीखेंगे, you will realize कि what actually sequences का beauty is. देखिए ध्यान से. So if I talk about S1, ध्यान से देखना, so this must be equals to n की जगह 1 और sum of terms must be 1. So ultimately you got the first term of the sequence as 1/2. S2 लिखना दिखाते हैं. S2 is the sum of two terms taking n का value as 2. So this will be reduced to 1/2 plus 1 plus 1/2 plus 2. Ultimately this reduced to 1/3 plus 1/3, and that is ultimately 2/3. So that is 0.67 something. This is 0.5. मैं फिर से कहूंगा, एक बार बच्चा बन के सोचेंगे, अच्छा लगेगा. ठीक है. And beauty of writing these observations, you will feel later on कि यार यूपीएससी में तो बच्चा वाला सवाल पूछता है. प्लीज, तो मेरे जो दिल का जॉय है ना, उसको यहां पर देखें. अब अगर कल को कोई आपसे कहे S3 क्या होगा, so take the n का वैल्यू 1, nth term is sum of n terms, so S3 will be sum of 3 terms. कहां पे, 1/3 plus 1, 1/3 plus 2, 1/3 plus 3. If you observe this, ध्यान से देखते रहना, 1/4 plus 1/5 plus 1/6. So if you observe this, sorry, check it out. This will be the term. अब ये जो टर्म है, इस वाली वैल्यू से ग्रेटर देन मिलेगा कि नहीं, बस इतना विश्वास दिला दो. Because the above is are you getting my point? सारे लोग. कनिष्क जोशी is commenting something. What? 1/3 plus 1/4. किसके लिए बोल रहा हो कनिष्क? ध्यान से देखना. Why I did this observation just like a child? Can you feel? देखिए, can you feel the sequence is monotonically increasing? बोलो हाँ या ना. the sequence is monotonically increasing. But my dear fellows, when you will write the answer, actual answer of the question, then you have to show. ध्यान से देखिएगा, when you want to show this, देखिए ध्यान से, अपने को दिखाना पड़ेगा Sn plus 1 minus Sn is greater than 0 for all n belongs to n. Means each term is increasing with the terms in S2 terms fraction sum. Namit, every one of you is suggested, just have patience, listen my words, don't struck over the one explanation which you have studied somewhere. ठीक है? What I say is, मैं बच्चे की तरह केवल ऑब्जर्व करने की कोशिश कर रहा हूं. मेरा बच्चा वाला दिमाग ये कह रहा है, बस कहां गलत होगा कहां सही होगा इसको तो बाद में देखा जाएगा. मेरी बात समझ रहे हैं? अब आप देखिए, मैथमेटिकली विदाउट शोइंग दिस यू कैन नॉट से दिस कि सीक्वेंस इज मोनोटोनिकली इंक्रीजिंग. राइट और नॉट? सो फॉर दिस ध्यान से देखिएगा, व्हाट यू नीड? You need to write Sn plus 1. So मेरे हिसाब से what Namit, what the explanation I have taken, this should be sum of n plus 1 terms where n will be n plus 1. My observation says like this. बाकी हम देखेंगे इसको. So if you observe, Sn plus 1 minus Sn will be what? Right or not? So if you observe my dear fellows, पहले तो मैं इसी का हिसाब किताब कर लूं. This is 1 upon n plus 2. This is 1 upon n plus 3. दिस इज 1 अपॉन, एक तो 2n मिलेगा, अगला मिलेगा 1 अपॉन 2n प्लस 1. द नेक्स्ट विल बी 1 अपॉन 2n प्लस 2. चेक इट आउट प्लीज. और बच्चा बनना है, ठीक है? बड़ा नहीं, बड़ा तो अभी बन जाएंगे, एक एक मिनट के आंसर सही है, उससे ज्यादा नहीं है. ठीक, बहुत बढ़िया. अब आप क्या करो, 1 में आपको Sn पता है, 2 में पता चल गया Sn plus 1. So Sn plus 1 minus Sn will be what? This term will be cancelled. This term will be cancelled. 1 upon 2n तक terms will be cancelled or not. Ultimately we will have 1 upon 2n plus 1 plus 1 upon 2n plus 2. These two terms minus का this वाला term. This is not cancelled by any term here. So minus 1 upon n plus 1. आराम से देख लीजिए. नमित प्यारे बच्चे, बोलो मैं सही या गलत? एकदम बच्चा लोग की तरह सोचना है, क्योंकि मैंने कहा ना, अलजेब्रा, एनालिसिस, जितना बच्चा बनेंगे ना उतना ही मजा आएगा. सुंदरम, अमित कुमार, कनिष्क जोशी, कोई दिक्कत? प्लीज रिप्लाई. फेयर, कूल, ओके, श्योर. अब आप देखिए, अगर मैं यहाँ से 2 कॉमन ले लूं तो n+1 विल बी अ फैक्टर हियर एंड बच्चा लोग की तरह सॉल्व करने में अपने को कोई तनाव नहीं है। एक तो 2n+1 एंड दिस इज 2n+1, so 2n+1, so this will become 2 times n+1, this is 2 times, so this will become plus 2n+1 minus 2 times 2n+1। आराम से देख लीजिए, n इज अ नेचुरल नंबर, कुछ तो कट जाएंगे यहाँ से, 4n कट गया, 2 + 1 3, 3 - 2 1, so that ultimately landed up with 1/2n+1, 2n+1. Since n is a natural number, so Sn plus 1 minus Sn is greater than 0 or not? ये क्वांटिटी greater than 0 है या नहीं? शिबू जायसवाल कहाँ गए? तुम्हारी बहुत चिंता रहती है मुझे। चलिए, so Sn plus 1 minus Sn is greater than 0. मोनोटोनिकली इंक्रीजिंग का मैथमेटिकल फॉर्म यही है। क्लियर और नॉट? सो व्हेन यू विल बी राइटिंग योर आंसर, you will just write this step and this step. You will refer, yes, Sn is a monotonically increasing sequence. Okay, dear fellows. Then you will ask, sir, what you were doing here? I was trying to make you feel, क्योंकि many of the times you will not be exactly getting this as simple calculation. In that case, you have to observe sequence के some terms and you have to get the feeling कि whether the sequence is increasing or decreasing. Did you get the point, everyone? I hope yes. So sequence हो गया increasing. Please be on the board. Now we are moving on the other point. Just be on the board, please, everyone. कि sequence Sn is bounded also. That is the question for us now. I guess दिख नहीं रहा होगा. Is it visible or not? Sn is bounded also. So for boundedness, एकदम बच्चा लोग की तरह ऑब्जर्व कीजिए. Since S1 is greater than 0, S2 is greater than 0, all are greater than 0. Say yes or no. देखिए ध्यान से. Since Sn is 1/n+1, 1/n+2 plus 1/n+n. टेक्निक सीखना है यहाँ पर. Be on the board, please, everyone. If I replace the denominator by a smaller quantity, the value will be increased or not. So this can be written as 1 less than. सभी लोग एकदम बोर्ड पर देखिए. Shundram, see what I have done. Here it is divided by, suppose that 1/5. So if I replace this by 1/4, obviously 1/4 will be greater than 1/5. So if I decrease the denominator, the value will be increased or not. So just for symmetricity, I have decreased all these denominators and I got the value here as, देखिए ध्यान से सब लोग, that is 1. Means Sn is less than 1. So if you include these two, what you have shown कि Sn is less than 1 but greater than 0. So what is your answer? Yes, the sequence Sn is bounded. आराम से बोलिए, किसी को कोई दिक्कत, कोई परेशानी? So sequence को we have shown कि sequence is monotonic. देखिए, monotonic and bounded. So sequence Sn is convergent. आराम से देख लीजिए. If you have any single doubt, you can ask. And whatever I have told you here, please like adopt that. You will feel the joy. Please write down properly. Is that noted? Please say yes or no. Everyone, is that noted? Okay. So I would like to go for one more example so that you can feel the beauty of monotone convergence theorem. So let's have a question. You people will try. I'll reply over the question. Example 2. Write it down please. So that the sequence xn where xn is 1 upon 1 factorial, 1 upon 2 factorial, 1 upon 3 factorial, plus 1 upon n factorial for all n belongs to natural numbers. Fair? अपने को दिखाना है so that the following sequence is conversant. If you are following this lecture series very sincerely, then I would like to suggest you, please do this exercise over this question. Believe me, by this second question itself, you will feel the joy of the process. But just like a child, याद करने की कोशिश करेंगे, that is the wrong way to prepare, है ना? Please note it down. Think about this. Roughly try कीजिए एक बार. Okay, चलिए. I hope you have tried. Now it's my turn, है ना? चलिए, एकदम बच्चा लोग की तरह सोचेंगे. नमित, are you there, dear fellow? चलिए, फिर से बोलते हैं. No matter how good you are in the process, I would like to suggest you just observe some terms of the sequence and develop this habit. सबसे पहला काम इसको एग्जाम पॉइंट करके यू कैन अडॉप्ट. सॉरी, ऑब्जर्व फ्यू टर्म्स इन स्टार्टिंग ऑफ द सीक्वेंस. कैसे करेंगे देखिए ध्यान से. सिंस the nth term is sum of n terms as xn क्या दे रखा है 1 upon 1 factorial. कहां तक 1 upon n factorial तक, right? So x1 will be sum of one term. एकदम बच्चा लोग किधर. x2 will be sum of two terms. So x1 क्या हो जाएगा just 1 upon 1 factorial. x2 will be 1 upon 1 factorial plus 1 upon 2 factorial. x3 will be sum of 3 terms. So x3 will be 1 upon 1 factorial. Please say yes or no. I guess आपको एकदम से अब आपको क्रिस्टल क्लियर पिक्चर हो गया होगा करना क्या है. Again I will say, the right way to prepare anything is never hesitate developing your basics. अभी कोई ये नहीं बोलेगा सर इस टाइप का क्वेश्चन अब नहीं पूछेगा करके. That is the wrong way to think. Getting? अभी a blind person can tell कि the sequence is monotonically increasing. बोलो, बोलेगा कि नहीं बोलेगा? विश्वास दिलाइए. Because this is this sum, so obviously this x2 is greater than x1. इसी को तो बोलते हैं ना मोनोटोनिकली इंक्रीजिंग. Say yes or no. So that was the observation part like a child. Now मैथमेटिकली अपने को दिखाना है कि वेदर इट इज मोनोटोनिकली इंक्रीजिंग और नॉट. Kanishk, how we will go? We will try to show xn plus 1 minus xn means difference of any two consecutive terms. अब n कुछ भी हो सकता है. So if it holds for this n means it can be generalized for all terms. So we start like this. When you will be writing the n plus 1th term, how it will be written? n plus 1 terms का summation minus xn क्या होगा? Up to where? So this comes out as 1 upon n plus 1 factorial. N is a natural number, so n plus 1 factorial is always a positive quantity or not? That is what you have shown. Xn plus 1 minus xn is greater than 0 for all n belongs to n. This implies what? Sequence xn is monotonically increasing. Say yes or no? बहुत बढ़िया. The next component is boundedness. Right. So for boundedness, there is nothing like very set pattern. That is the exam point for you. There is no set pattern. You have to develop this habit by the rigorous practice. ठीक. अब आप कहेंगे सर कितना क्वेश्चन करना पड़ेगा? भाई मलिक अरोड़ा कोई भी बुक आप उठा लो, वहां के जो एग्जाम्पल्स हैं सीधे सीधे आपको एग्जाम में मिल जाते हैं. अगर थोड़ा सा चेंज भी करता है तो मलिक अरोड़ा के एग्जाम्पल्स सारे अच्छे से करने के बाद जो हैबिट डेवलप होगी आपकी, दैट विल बी मोर देन सफिशिएंट टू टैकल दोज क्वेश्चंस. आई एम वेरी मच सॉर्टेड ओवर दैट. ठीक है, चलिए. सो फॉर एग्जाम्पल अगर मुझे इसका ऑब्जर्वेशन करना है कि ये बाउंडेड किससे है, तो उसके लिए व्हाट आई एम सॉरी, ध्यान से देखिए. वी विल start from writing the term xn. Be on the board please everyone. Now that much I am clear कि सीक्वेंस का हर टर्म is greater or equal to 1. Check it out. Each term of the sequence is greater or equal to 1. I am trying to get what is the upper bound now. Yes or no? So to get the upper bound, obviously I will try to decrease the denominators. Fair? ध्यान से देखते हैं ना इस बात को. अब देखिएगा, if I observe 2 factorial, if I take the next term as 3 factorial, so if I do this, एक बार ऑब्जर्व करके देखना, फिर बात आगे बढ़ाएंगे. Just wait a minute, there is no set rule for that. It depends on our practice and observation. So factorial के लिए I have went like go like this. अब ये कैसे गया? Since 2 is less or equal to factorial 2, 2 square is less or equal to factorial 3, 2 cube is less or equal to factorial 4, and so on. So you can mark the star here, and today onwards you will have this as an instrument with you. Fair? So this is a series. क्या है? एक ज्योमेट्रिक सीरीज आपको मिल रहा है जिसका कि समेशन बचपन से हम जानते हैं क्या होता है, a इंटू आर का पावर n, अगर ये r लेस देन 1 है तो r 1 माइनस r का पावर n काइंड ऑफ स्टफ यू कैन राइट, राइट. So this will be a into r का पावर n minus 1 divided by r minus 1. So depends on the scenario, either you take minus upper side, lower side, both में. So the number will come out as positive for that. So abhi if you observe that number, what can it be? Check it out please. So नीचे वाला नंबर हो गया 1/2, 1/2 से 1/2 कैंसिल हो गया. So that is 1 minus, where it is. So ये नंबर 2 से बियॉन्ड जाएगा क्या? ओके, ठीक है. Just give me 1 minute please. I can write that in better ways. A is 1 here. I have done this. Second term में स्क्वायर है, थर्ड में स्क्वायर है, फोर्थ में क्यूब है, तो nth में n minus 1 होगा पहली चीज. So n minus 1, this is sum of the n terms. So this will be, check it out. A 1 minus r का पावर n upon 1 minus r kind of stuff. ठीक है. If you observe this clearly, definitely you will be getting this value as less than 2. If you are like having any single doubt, just manage the expression like 2 का power n minus 1 kind of, और नीचे जो 1 upon 2 है वो ऊपर भेज दीजिए. You will have some expression like this. चेक कर लेना, एक -1 से बाहर आएगा. So for n tends to infinity, this number will be less than 2. Check it out. आराम से देखिए, कोई दिक्कत होगी तो मुझे बताइए. So what you can say, xn is lying between 1 and 2. Please say. Monotonic कहाँ गया? Now, by monotone convergence theorem, what you have? Xn is convergent. Because a sequence which is monotonic and bounded will be convergent. Please note it down. कोई डाउट होगा तो बोलेंगे. Now please tell me, is there anyone जिसको मोनोटोन कन्वर्जेंस थ्योरम का फीवर है अभी तक? इजी ना, जस्ट बच्चे की तरह. And these are very standard processes, okay? When you practice the things, these will be automatically settled in your memory. Is that noted? Is that written? Okay. So we will be like increasing the level example by example. Okay dears, be on the board please everyone. अब देखिए, we will take another example and we'll try to explore more. The question is, check the convergence of the sequence xn defined by the recursion formula. Don't confuse by the word, it is just मतलब अगले टर्म को पीछे के टर्म्स के साथ फॉर्म में लिखना, that is recursion. Okay, the next term can be written in the form of the previous term, that is recursion. By the recursion formula, xn लिया है तो xn plus 1 equals under root 3xn, comma x1 is 1. ठीक है, check the convergence. If it is convergent, then find the limit of sequence. ठीक है प्यारे बच्चों, what I will suggest to you guys here, this is a question multiple times you will find in your CSE and forest services. Okay, but I'm not interested कि वो पूछा है या नहीं पूछा है. I know कोई भी बेसिक बुक उठाएंगे, you will have such questions, there is no issue at all. I am more interested in decoding the problem. ठीक है, Let's decode it. Be on the board, please, everyone. एक वर्ड यूज हुआ रिकर्जन, राइटिंग नेक्स्ट टर्म as in previous terms तो उसमें कुछ ऐसा नया नहीं है. If you observe the example 1 and 2, their nth term was given. Here nth term is not given, but nth term depending on something that is given. Fair? So how to deal such things? Be on the board, please. देखिएगा ध्यान से. Observation part will be very crucial while dealing such problems. देखिएगा ध्यान से. x1 is 1. So by given formula, x2 will be under root 3x1. Say yes or no. So this will be under root 3. If you observe x3 क्या होगा, that will be under root 3x2 and eventually turned out to be 3 root 3. मजा आया कि नहीं? that is sequence xn is of the form please say yes or no. So the observing terms habit will definitely help you. And to discuss these things, that is why I started developing that habit from the example 1 itself. Right? अभी थोड़ा सा मजा आ रहा है करके कि यार हैबिट डेवलप है अपने अंदर ऑब्जर्वेशन की. टर्म्स क्या दिखेंगे. So any blind person can tell you कि terms are increasing. बोलो हाँ या ना. So this sequence is monotonically increasing. That is the observation. क्या है? Observe monotonically increasing. Right. But केवल ऑब्जर्वेशन से काम नहीं चलना है. We have to show mathematically. For such recursion formulas, mathematical induction method will come into picture. What method? So mark the star here and say it is an exam point for you. What it says? To show monotonic, we will use mathematical induction method. So persons who attending regularly lectures, they know while I was teaching algebra in the second lecture, first में तो lecture ही planner देता हूँ मैं. Second lecture I told mathematical induction. If you haven't attended that, today I am telling you again. देखिएगा ध्यान से. How this method works. Since x2 is greater than x1 or not, because under root 3 का value is 1 point something. So x2 is greater than x1. Right? ध्यान से देखिएगा. Let if कैसे मैथमेटिकल इंडक्शन करता है. सपोज दैट इट होल्ड्स फॉर n इक्वल्स टू 1, n इक्वल्स टू 2. लेट इफ इट होल्ड्स कि xm इज ग्रेटर और इक्वल टू xm माइनस 1, देन चेक. इफ वर्ड को हाईलाइट कीजिए. इफ दिस होल्ड्स, देन चेक if xm plus 1 greater or equal to xm or not? If that holds, then we will say it will hold for all natural numbers m. That is the mathematical induction method. Clear है बात? So when you will try to decode these problems after one or two revisions, you will be settled in your mind कि यार ये इतना सेट पैटर्न होता है कि अपने को एकदम से हट जाता है दिमाग में कि हाउ टू प्रोसीड. Clear? Although I never say to cram to mug up the things, I always say try to decode it in the right way. Clear? चलिए. So can you try this? देखिए ध्यान से. That is, if xm will be what? If you observe from here, that will be under root 3 xm minus 1. This is greater or equal to under root 3, ध्यान से देखिएगा, under root 3 xm minus 1 must be like this or not. Clear है? What we want to show? We want to check whether this will hold or not. Check it out. क्या करना है? Using this, you have to reach here, and you will be concluded as simple as possible. Kanishk, Amit Kumar, will you try it, please? Will you try it, please? How you will write that actually? And writing that is an art. एक ही लाइन होती है, लेकिन मैं जानबूझ के टाइम ले रहा हूँ, because I know एक बार सेटल हो गया अगर दिमाग में तो मजा आ जाएगा. Try it please. Anyone tried? नहीं किया, कोई बात नहीं. So here I am telling you how mathematical induction works. Fair? चलिए, be on the board please. देखिए हम इसको कैसे लिखते हैं, ध्यान से देखिएगा सब लोग, सारे लोग बोर्ड पर रहिए. Amit Kumar is writing something. What you are writing, Amit Kumar? मैं बोलूं क्या? देखना ध्यान से. This was the try. Okay? अभी देखेगा. Since xm is greater or equal to xm minus 1, this implies if I take the square root and multiply by 3, that will also hold or not. बस इतना विश्वास ला दीजिए भाई. नहीं समझ में आए तो ऐसे लिखिए, अगर a greater than b है तो अंडर रूट 3a विल बी ग्रेटर देन अंडर रूट 3b. एकदम बच्चा लोग की तरह। ओके डियर फेलोस, दिस implies under root 3xm, this is nothing but xm plus 1, this is nothing but xm, यही तो शो करना था। देखिए, from here we wanted to reach here and your job is done. So what was the crucial part my dear fellows? आराम से देख लीजिए, कोई डाउट है तो बताइए। हमने यहां पर भी वैल्यू रखने की भी कोशिश की, ट्राई किया, फंसे, फिर निकाला आपको बाहर, और आज के बाद दोबारा नहीं फंसेंगे, क्योंकि अपने ने क्या लॉजिक अप्लाई किया है, दैट इज क्लियर। सो व्हाट यू विल से, तो ये क्या इंप्लाई करेगा, दिस इंप्लाइज कि इट होल्ड्स फॉर m equals to 1 and if we take it as holding for m equals to k, we have shown it also holds for m equals to k plus 1. So by mathematical induction method, it is true for all m belongs to n. That is, you have shown, that is सीक्वेंस xm या फिर xm greater or equal to xm minus 1 for all m belongs to n. This implies sequence xm is monotonically increasing. Mathematical induction method is clear to all or not? एकदम जिम्मेदारी के साथ आंसर दीजिए, मजाक बिल्कुल नहीं। क्रिस्टल क्लियर है या नहीं? नोट डाउन प्लीज। इतना सा गेम ना एग्जाम में आपके मार्क्स डिडक्ट कर देता है। क्यों? क्योंकि आपने रट्टा लगा लिया होता है मलिक अरोड़ा से, लॉजिक सोचते नहीं है कभी। प्लीज राइट डाउन प्रॉपरली प्लीज। Let me check the comments of yours as well. Kanish Joshi, right? Kanish Joshi, you are correct. You are correct. हमें हाँ मैथमेटिकल इंडक्शन ही तो पूछ रहा था। Please write down properly everything. Limit is 3. Okay, we'll check that. Not an issue. चलिए, so the observation part we had done. We had mathematically shown कि whether that is monotonic or not. We found that is monotonically increasing. What is the next step now, my dear fellows? Boundedness. Say yes or no. So when you talk about boundedness, again, if you observe x1 is greater than x1 is 1, x2 is root 3, x3 is under root 3 root 3 and so on. So if you feel observe the pattern of this sequence xn, so what you found, my dear fellows, कि ध्यान से देख, x1 is x1 कहाँ गया, x1 1 दे रखा, ठीक है, x2 ले सकते हैं, so x1 is, देखना ध्यान से, x1 is less than 3, x2 is less than 3. Now we, आराम से देखिएगा सभी लोग, be on the board please everyone, एकदम बच्चा लोग की तरह. Let if xm is less than 3, then xm plus 1 is also less than 3. मैथमेटिकल इंडक्शन आज नहीं चमका तो कभी नहीं चमकेगा. अमित कुमार, what it holds? It holds for n equals to 1, it holds for n equals to 2. This comes from observation only, right? हमने क्या किया, let if this holds for this, then whether this holds or not. And if you got this as conclusion by using this, by mathematical induction, it will hold for all natural numbers m. So what you will do now? Please reply. What you will do now? किससे मल्टीप्लाई करें? देखिए ध्यान से, दिस इंप्लाइज 3 से मल्टीप्लाई करके स्क्वायर रूट ले लीजिए, ठीक बात है या नहीं? By the given recursion formula, this is what? xm plus 1. So this is less than 3 or not? बोल दो हाँ या ना, बस इतना बोलो. So what you have observed, my dear fellows? Your answer is yes. So by mathematical induction, so what you have shown, अभी मैं इसको नीचे कर देता हूँ थोड़ा. I guess it won't be visible. Just wait a minute, please. So, by mathematical induction method, sequence xn is bounded by 3. So, my dear fellows, these are two crucial parts where you need to have the practice. That's it. Monotone convergence theorem के questions are very beautiful, but my dear fellows, as much as you are in the practice of doing these observations, you will be feeling very easy in this exercise. So now it is bounded, it is monotonic. So by the monotone convergence theorem, given sequence is convergent. So by monotone convergence theorem, sequence xn is convergent. Say yes or no. everyone? So by monotone convergence theorem, given sequence is convergent. पहले इतना लिखिए, फिर बाकी देखेंगे लिमिट क्या है, लिमिट पर भी बाजा बजाया जाएगा. Is that noted? Okay, yes. So the second part is to get the limit now. So what the conclusion we have till now? The given sequence is convergent, right? So one part of the answer is remaining. I will do that here. Okay, dear fellows. देखिएगा, कंटिन्यू करेंगे. Be on the word, please, everyone. Since sequence xn is convergent, right? So it has unique limit. So it has unique limit. Let's say L. Fair? So if I say limit n tends to infinity, xn is L, or limit n tends to infinity, xn plus 1 is also L, means limit of a sequence is L. तो either I leave some finite number of terms, तो उससे तो कोई फर्क पड़ता नहीं है. So means for a convergent sequence, I can write the limit xn is L, that eventually will like indicate as कि limit xn plus 1 भी L ही होगा, limit xn plus 20,000 भी L ही होगा, because convergence का basic meaning I have clearly told you in the first lecture of sequences. Convergence means what? L is the limit of the sequence if all but finitely many terms of the sequence are situated at the point L. So let's do that. So by using this, since we have been given xn plus 1 as 3xn, ठीक है, so this implies limit n tends to infinity xn plus 1 limit n tends to infinity under root 3xn, right or not? So this can be written as L under root 3L, fair, क्योंकि लिमिट xn भी L ही है. This implies L square equals 3L. This implies L L minus 3 equals 0, 0 or L equals to 3. This is not possible. क्यों नहीं possible है? If you observe terms x1 जो है that is greater than 1, right? So limit cannot be less than 1 because all terms are of the sequence are lying between 1 and 3. So this is not possible. So limit n tends to infinity xn equals L equals to 3. So what is the answer of the second question? Limit of sequence xn is 3. आराम से बिल्कुल एकदम बच्चा लोग की तरह है. If you have any doubt, please ask. Shundaram, is that clear, my dear fellows? If the sequence is proved as convergent, then how to get the limit of that sequence? This is process of finding limit of the sequence. Once it is proved that sequence is convergent. Okay dear, please note down. लिख दीजिए आराम से. Noted? Everyone? Fair. So अभी what I suggest you guys after today's, अभी तो हमें इन दोनों पर भी बात करनी है. We will finish these as well. After today's session, I will share the PDF of the Malik Arora example itself. है ना? क्योंकि अभी वो typed नहीं है. But I will say whatever the approach I am trying to develop here, if you practice those examples only, I'm not talking about exercise even, only examples, ठीक है, you will have the sure shot confidence for your both of the exams. ठीक है, कोई दिक्कत? conceptual clarity with examples within the peripheral of demand of exam I have done for you. For monotone convergence theorem, now after solving those examples, बहुत स्टैंडर्ड एग्जांपल है, एक हार्मोनिक मीन वाला है, ठीक है ना, एक इवन ऑड इंडिसेस वाला है, वो एग्जांपल्स है, सीधे सीधे क्वेश्चन पूछ लेते हैं, ठीक है. So you people can handle those examples now. I'll share the PDF after the session. I will move on Bolzano B.Sc now. Baki, after solving the those examples, if you come across any of the doubt, I will definitely take the problem solving session as well. देखिए, so these are just बच्चा वाला खेल now, है ना, बोलजानो B.Sc, इसका बाजा बजाते हैं, ठीक है. Be on the board please everyone. उस दिन मैं कितना मूड में था ये तो मुझे बाद में पता चला. बोलजानो B.Sc देखना ध्यान से, मतलब if you want to prove you can as well, not an issue at all, but before that the feelings part is very much requisite here. Be on the board please everyone. देखिए, from set theory what was the BW theorem? बोलजानो B.Sc theorem क्या था? Please reply. शिबू जायसवाल, कनिष्क, अमित, एवरीवन. बोलजानो B.Sc थ्योरम फॉर सेट्स क्या था? जल्दी बोलिए, पीटूंगा मैं. Please reply. Every infinite bounded set has at least one limit point or not? क्या था? Every infinite bounded set has a limit point. ठीक था? यहां पर आइए BW पर, देखिए, every bounded sequence has a convergent subsequence. ठीक है? This is the statement of Bolzano B.Sc for the sequences. अब देखिए how to think, how to visualize this. Be on the board please. आगे शुरू कीजिए. देखिए ध्यान से. How to think. देखिए ध्यान से. Let if sequence xn is bounded. Fair. This implies we can construct a subsequence of sequence xn whose terms are monotonically increasing. ध्यान से देखते रहिए. What they said कि the sequence is bounded. They didn't say anything about कि it is increasing, decreasing, something like that. Not at all. अगर आपको visualize ना हो, I have already told you the methods to visualize, right? Be on the board, please. For example, देखिए, if you take a sequence xn which is 1 minus 1 2 minus 2, fair, again 1 minus 1 2 minus 2 and so on. Okay, clearly sequence xn is bounded. ध्यान से देखना. Now let's take out a subsequence by n which is nothing but some terms, like suppose that मैंने x1 उठा लिया, ठीक है, ध्यान से देखते रहिए. I have taken x1, then I have taken this वाला term x2 x3 x4 x5, then I have taken x9 and so on. So this will be a sequence of the form of this or not. This is monotonically increasing and bounded, so convergent or not. Similarly, you can construct other sequences as well. So if someone asks you कि भाई write the proper proof of Bolzano-Weierstrass for sequences, आराम से you can start thinking like this. So which are monotonically increasing. Fair? Now इसको 1 number डाल. Since sequence is bounded, so subsequence will also be bounded. So what you found? By 1 and 2 subsequence is convergent. So Bolzano-Weierstrass के different forms में we state, but ultimately the crux of Bolzano-Weierstrass is this only. I hope this will be crystal clear to you all. Please madam. Every bounded sequence has a convergent subsequence. Please mark here star, and it is an exam point for you. आराम से देखिए, एकदम पूरा बेहतरीन क्लैरिटी के साथ में. Is that written? BW theorem for sequences. Okay, yes. I hope everyone has noted, right? So please do remember this statement. That will help you eventually. Every bounded sequence has a convergent subsequence. Do remember. इसको भी exam point लिख लीजिए please. Write the statement as an exam point. Okay, dears. देखिए ध्यान से, जैसे BW क्लियर हो गया अभी. Cauchy sequences is a very wonderful concept. Also, if you observe your PYQs, you will find sometimes in your this sequences wala chapter, they may ask prove or cross verify the given sequence is Cauchy sequence or not. So, can anyone tell me what is Cauchy sequence? कोई भी एकदम मेरी तरह जो बच्चा होगा, एज वाइज नहीं. Namit, what is Cauchy sequence? Kanishk, and today I will make you visualize this very beautifully. आज के बाद भूलेंगे नहीं आप, I can guarantee. What is Cauchy sequence? Okay, Kanishk has replied something. Let me check it. Hey, Kanishk, I'm not asking the result, yaar. I'm asking definition. You are old student, yaar. You forget my way of teaching or learning. Result comes after the definition. So I'm asking about the definition of Cauchy sequence. I'm not expecting you to have the proper definition, just like for creating that curiosity in you. Amit Kumar, modulus of xn minus m less than epsilon. थोड़ा भारी भरकम हो गया यार अमित, थोड़ा बच्चा लोग की तरह समझाइए. चलो, लेट्स एंजॉय इट नाउ. ठीक है गणेश, देखते हैं सारी चीजों को. राइट द हेडिंग प्लीज. Cauchy sequences. सभी लोग बोर्ड पर रहेंगे और ऑब्जर्व करना. यस नमित, यस, यू आर वेरी मच क्लोजर. चलिए देखिए ध्यान से. ए सीक्वेंस xn is said to be a Cauchy sequence if the difference between terms all but finitely many. Okay, I guess you people have the clear cut picture for these things right till now. Say yes or no. ठीक है, शुरू देखते हैं. Is very small. That is, इसको कैसे बोला जाता है? That is after some some finite number of terms, after some finite number of terms of the sequence get closer and closer. बहुत बच्चा लोग की तरह, बहुत बच्चा लोग की तरह देखना ध्यान से. For example, if I ask you, let's consider a sequence that is 1, 1 by 2, 1 by 3 and so on, right? So if you observe, chalo, this is 1, this is 0, this is 1 by 2, then 1 by 3. If you observe, after some finite, let's say 20,000, terms are coinciding at the point 0. I am not telling the convergence. I am telling, for example, if you talk about, देखना, for example, difference between x 20,000 and x 20,001, or difference between x 200001 and x 2000, very closer, that is difference is 0 almost. Terms के बीच का difference getting very closer and closer. Where? अब इसका मैथमेटिकल फॉर्म देख लेते हैं. Mathematical form. Be on the board, please, everyone. Sequence xn is said to be a Cauchy sequence if for every given epsilon greater than 0 there exists positive integer m, obviously depending on the value of epsilon, कितना डिफरेंस आप ले रहे हैं, such that modulus of xn plus p minus xn is less than epsilon for n greater or equal to m and p is greater or equal to 1 something. ठीक है, आराम से एकदम बच्चा लोग की तरह, बिल्कुल पैनिक नहीं करना है. चमका ना दिया आज एकदम. ये वाली डेफिनेशन भी आपने रट्टा लगाया था, लेकिन कितना समझ में आया मेरे को तो एज ए स्टूडेंट तब समझ नहीं आता था. Honestly speaking, later on I realized कि यहाँ P क्या है, यहाँ M क्या है, like that. देखिए ध्यान से, if you talk about here P is greater or equal to 1, देखना ध्यान से. For example, if we take M as 20, fair, then we want, देखिए ध्यान से, xn plus 1 या xn plus 2 या xn plus 20,000 and so on. I guess the picture will be crystal clear. और इसी का एक्सप्लेनेशन ये है या नहीं, बोलिए, विश्वास दिलाइए. Is there any student who didn't get the message of Cauchy sequence? So Cauchy sequence is defined like after some finite number of terms, the difference between the terms getting very closer to 0. That is the Cauchy sequence definition. In case of real sequences, what it says? In case of real sequences, Cauchy implies convergent and convergent implies Cauchy. So that is the exam point for you. If you are interested in mathematical representation, that I can do as well. But for you need to remember this. देख लीजिए आराम से. And by this explanation, you can get over these things as well without any hesitation. Is everything visible? Can you make it confirm, please? कहीं कुछ ऐसा तो नहीं है जो दिख ना रहा हो? हाँ, if you change the like आपका स्पेस जब चेंज हो जाता है तो वहां पर जैसे मान लो कोई सीक्वेंस है, if you have taken the sequence in the set of rational numbers which is converging to root 2, तो root 2 is not a rational number, means फिर वो जो सीक्वेंस वहां पर बनेगा वहां Cauchy convergence imply नहीं कर पाएगा. I have very beautiful examples as well, लेकिन पहले आप इसको समझिए. बहुत मजा है अपने पास. Okay, Amit. Everyone, is that noted? See, dear fellows, as I always suggest, we have to limit ourselves in the peripheral of our demand of exam. As far as my strategy is concerned, for me, if they are asking whether some given sequence, ध्यान से सुनना, whether some given sequence is Cauchy sequence or not, fair. So, एक तो just one or two examples are there which are always in every of the book. So the PDF which I will share, in that also you will get that example. So for that, the process I have already taught you very exclusively how to work with such expressions. In the lecture 1 itself, I taught you the way to handle such expressions. So to check whether some given sequence is a Cauchy sequence, we have two ways. Number one is getting by this expression, other is since our syllabus is to deal with the real sequences only, for real sequences convergence imply quasi and quasi imply convergence. So for our exam we will be very smart कि भाई whenever they are asking some quasi sequence कि है या नहीं है, we will simply check the convergence of the sequence. If it is convergent, then for real sequences it is quasi as well. Fair? So what is the exam point for you? If you want to write, please write on your paper. लिखिएगा exam point में. To check the quasi sequence, we have two ways. Write down please. To check the quasi sequence, we have two ways. Way one, through the definition. Way one, through the definition. Comma, the process is similar as we did for convergence of sequence in terms of epsilon. ठीक है, like epsilon delta definition है ना. Way two will be what? We go way two में लिखिए, we check the convergence of given sequence. We check the convergence of given sequence by the ways of convergency learned previously. And if it is convergent, we say it is quasi also, because in case of real sequences, every quasi is convergent and every convergent is quasi. So learning the things beautifully with the definitions per focus, I have tried my best to make you feel real sequences का gesture. अब देखिएगा, be on the board please everyone. I will share some examples. You people are expected to go through those examples. You have already PYQs file. Chapter wise PYQs are arranged in that. So real analysis में real sequences वाले PYQs, please observe those. Within the stuff, limit superior, limit inferior, ये सब मारिए गोली. मेरे को भी पढ़ना बहुत आता है, पढ़ाना बहुत आता है. But I will never forget what is the demand of my exam. You getting my point? So if you ask to me कि sir real sequences के लिए what is the summary you would like to draw? What is the summary? Be on the board please everyone. सभी लोग. So the very first point ये किसके लिए है? For the time of revision. Definition. Very sorry. Definitions को फोकस करना है. Like sequence क्या है? Limit point of a sequence is what? Limit of a sequence is what? Convergence of a sequence means what? So if you cross-examine the lecture 1 of sequences, you will get clear-cut explanations for these answers. Once you develop this, the next step is to check the convergency. For that we have studied subsequences, we had studied monotonic sequences and bounded sequences. Through this we went on monotone convergence theorem. This is the very beautiful theorem जिसके लिए हमने multiple examples भी किए. You people have to practice by solving and observing each step, my personal suggestion for you is that if you miss this process, you will lose the game. ठीक है? Then we went on BW theorem, right? To remember the statement and the Cauchy sequences. If you observe कि sir to check convergence, what are the instruments we have? I have also already told in some like second lecture, I guess. Number one is epsilon definition. पहले तो ऑब्जर्वेशन पे ही आप कर सकते हैं, ऑब्जर्वेशन बेस्ड. Number two is epsilon definition. Number three is finding limits. So for this you will just practice limit calculation के बारे में. Already we have enough exercises in the indeterminate forms. यहाँ पर एक्स्ट्रा में कॉसी थ्योरम और सिजेरोस हैं, बहुत ज्यादा पढ़ने की जरूरत नहीं है. जस्ट इफ लिमिट n टेंड्स टू infinity an is L, then limit n tends to infinity a1 plus a2 plus an by n is also L. That is the Cauchy first theorem. Sometimes we use this, otherwise fundamentals जो हैं limit calculations के, those are like the differential calculus which we had already done. The next part is monotone convergence theorem, right? Ultimately the part is Cauchy implying convergent and convergent implying Cauchy. So the whole scenario of real sequences runs like this. If, again I am saying, if you have done this much mental exercise and the PDF which I will share with you, if you solve those examples only, believe me, no need to wonder here and there कि इसमें अच्छा क्वेश्चन है, उसमें अच्छा क्वेश्चन है. मेरी बात जितना मान लेंगे उतना तसल्ली में रहेंगे, ठीक है? So please write down this as well, and I will suggest never forget to do this mental exercise. Otherwise प्योर मैथ्स पढ़ना पढ़ाना मुझे भी बहुत आता है, लेकिन एग्जाम के हिसाब से सिस्टमेटिक लर्निंग, कॉम्प्रिहेंसिव वे में कैसे चीजों को समराइज करना है, दैट इज द पार्ट ऑफ अवर प्रिपेयर इन लाइफ. प्लीज राइट डाउन दिस एंड ऑलवेज रिवाइज लाइक दिस ओनली. क्लियर? सो आई एम गिविंग यू अ होमवर्क, जो पीडीएफ करूंगा करके उनके एग्जांपल्स ओनली. सॉल्व दोस, सॉल्व प्रॉपरली. Okay dears, so it is enough from my side for today. I don't know आप में से कितने लोग मुझसे नाराज हैं, पर dear fellows, please, I am literally sorry actually. चीज़ों को डिले नहीं कर सकता आप. और दूसरा ये भी आप कह सकते हैं कि सर आप मतलब थोड़ा सा ग्रीडी हो रहे हैं. I will just simply say there are lot many responsibilities which you can never divert. But as a teacher, I always try to give my best. So बीच में जो lag आ रहा है, that is because of my family responsibilities and all. We're literally sorry for that. But I'm committed. Whatever I said, I will follow that. Try to do my best. Okay? So again, it's up to you how you take the things. But yes, I will be trying my best. जितना पॉसिबल होगा, जहां पॉसिबल होगा, आई विल टेक द लेक्चर. ठीक है? बाकी क्या बोलूँगी? Sign up from my side. We will meet by tomorrow. I'll message. Probably we can start either the PYQ session tomorrow, or we can start the real infinite series. Sequences and series is a one block for us, right? Sequences का we have done. एग्जाम्पल्स में कोई डाउट आएगा तो आई विल कंटिन्यू विद दैट, अदरवाइज सीरीज स्टार्ट कर लेंगे कल. इज दैट नोटेड? यू कैन हैव द स्क्रीनशॉट एज वेल. Okay dear, so it's enough. Bye, good night. कॉपरेट करेंगे थोड़ा सा, है ना? मतलब पता नहीं, मुझे अंदर से ऐसा लगता है कभी कोई मेरे बारे में ऐसा ना सोचे सर ग्रीडी टाइप का था, पहले कुछ बोला कुछ किया करके। ऑल दो जितना कोशिश होगा मैं मेरा बेस्ट करूँगा। 15 जनवरी से 10 फरवरी जो ऑफ बोला है, उसमें भी जब भी मौका लगेगा मैं क्लास जरूर लूँगा, जब भी मौका लगेगा। ठीक है डियर्स, गुड नाइट एवरीवन। एनीवन वांट्स टू से समथिंग, आस्क समथिंग, यू कैन आस्क। अभी तो फॉर द टाइमिंग आई विल सजेस्ट यू गाइस revise classes properly without any hesitation. Depend on classes because I have summarized everything whichever required, and things which are just कि हाँ बस रियल पढ़ रहे हैं सब कुछ लेटर पटर जो भी है सब पढ़ देंगे करके, वो वाला पार्ट मेरा वे नहीं है, ठीक है। वेरी मच प्रिसाइज, वेरी मच सो दैट अपने को पता रहे एग्जाम में कैसे परफॉर्म होगा। तो फिलॉसफी बिल्कुल भी नहीं पढ़ेंगे हम, ठीक है। ओके डियर्स, गुड नाइट एवरीवन। कॉसी वाले क्वेश्चंस भी ट्राई कर लेना, बाकी हम कल डिस्कस कर लेंगे कुछ क्वेश्चंस को। मैथमेटिकल इंडक्शन कैसे वर्क करता है, ये सब चीजें फोकस करने वाली है। कैसे मोनोटोनिक दिखाना है, कैसे बाउंडेड दिखाना है, those are the points and those are depending on observation. What you are asking? Okay, Namit. Thanks for understanding. Thank you, Namit. Thank you, everyone. Actually, I know you people will understand my feelings as well. Fair it is.